identifying strategies to reduce flood risk in the central San Rafael Valley and how to move forward to respond to sea level rise. We have a couple of key team members. Stuart Siegel is a wetlands biologist and PhD, and he's on our team. And we also have other folks like Kathy Schaefer, who is with FEMA, who really is focused very much on dealing with flood risk and flood insurance. So let's start off by saying, first off, the issue really is this resilient by design challenge is a wonderful opportunity for communities all around the Bay Area. And we are really grateful to both the RBD project and also to the Bionic team for focusing resources here in San Rafael. We've known for quite some time that we've had some challenges here in San Rafael, and we had to bring attention to our community to focus resources here. Fortunately, when the 10 teams were looking at various different sites around the Bay Area, the Bionic team really focused on San Rafael. 3 other teams did as well, but ultimately San Rafael was selected as one of the sites. And what that did is that brought a tremendous amount of resources to our community. There was a lot of research done by Team Bionic and the other teams on what really is going on here, about the topography, about human settlement, about environmental issues, and it's that legacy of information that we're going to benefit from as a community, as well, of course, as some of the design ideas and the basic questions that are being raised by Team Bionic. So that means really that we've had an opportunity to learn a lot more and get all of you and many others engaged in this issue of how do we as a community deal with flood risk and look forwardly at how we as a community will manage with sea level rise. So I want to touch on a few things just to sort of dig down a bit further on some of the things that Marcel mentioned. The first of which is the valley floor here in central San Rafael was, up until basically about the Second World War, a large salt marsh. And virtually all of the level area in the valley floor itself has been filled. And that area, after you fill it and you put human settlement on it, subsides slowly. And as a result, much of the area, particularly in places like the Canal neighborhood proper, would be below the water level at high tide. And the only thing that keeps it from getting wet is the levee system, which Marcel mentioned. In all, there are roughly about 16 to 18,000 people that could be flooded in a 100-year flood. And that event would occur when we would have something like a king tide, as well as a major atmospheric river hitting us simultaneously. So we'd kind of get hit in both directions, by the sea and by the water coming off the land. So that challenge is exacerbated by the fact that our little shoreline reach has over 10 miles of shoreline when you consider the shore along the estuary that extends all the way into downtown San Rafael. So we may think, oh my God, there's nothing we can do, but in fact there's a great deal that we can do. And as a community, what we need to do is we need to find ways to address the needs of all the various different interest groups, environmental groups, landowners, people that provide services like our fire department and our public works department, also bicycle interests and homeowners. All of you have interests. And what we can do as a community is focus on those things that we share, and then we will be able to find solutions. Today, we're going to have an opportunity to have a closer look at the actual conditions along the canal, not only environmental issues and habitat and wildlife and approaches that we're taking to creating living shorelines, but also human culture along the shore, those areas that are at risk. And one of the things that I'd like to point out, for starters, is when you look across at that boat that's now half sunk in the marina, what you're looking at is a significant amount of low-cost housing. People who live aboard boats are commonly folks that would not otherwise be able to live here in San Rafael. So we're going to see lots of different interesting things about cultural geography, human settlement on the landscape. And I think that today I'm hoping that you'll find this all exciting and interesting, and we're incredibly grateful to Urban Studios and to all of our experts here today. Thank you all for coming.
Thank you, Jeff. So I'd like to invite Kathy up, and Diana Benner, and Stuart. And we'll just have a little conversation about what we're going to see out on the water that's relating to a lot of both the watershed issues, the canal settlement here, and out into the bay. So the tour will take us on several projects that are currently underway and experiment with approaches to creating habitat and promote adaptation strategies to climate change. The first one is going to be our stop at the living shorelines out in the bay. So Kathy, I'd like to start with you. Oysters are being used in many pilots throughout the country. In New York, there's the Billion Oyster Project, which is a very large-scale restoration project in New York Harbor, growing 1 billion oysters and 100 acres of oyster reefs. In the Chesapeake Bay, homeowners have been given native oysters to grow from their piers, ready to be transplanted into protected marine sanctuary in a community-based oyster gardening program. So can you describe how oysters are being used in the San Francisco Bay?
Sure. All right. Thank you all for coming. Again, Kathy Boyer. I'm a professor in biology at San Francisco State, and I'm based at the Estuary and Ocean Science Center, which is in Tiburon, and have had a lot of interest around the San Rafael area for quite some time, in part with oyster restoration, in part with eelgrass restoration and tidal marsh restoration. So I am an ecologist, and I work on largely restoration type work, trying to understand what we can do to create habitat and keep it going in the future with sea level rise in particular. So oysters are something we've been working on for a while. I'm part of a large team of people who has been working on issues of oysters and how to restore them and what they can do for us. And you'll meet Marilyn Latta here at some point later today as well at the Coastal Conservancy, who's been leading up a lot of that work. But we're really interested in what oysters can do for food, for physical structure, and for habitat in general. And so when we can get native oysters established, our little native oyster, the Olympia oyster, is about this big, and maybe we'll get a chance to see some of those out on the Living Shorelines project that we'll show you by Kayak. And they are eaten by all sorts of other things. They provide a substrate for other things to attach to. So they create a habitat, and we're really interested in that in particular. Now, when we build some kind of a structure for native oysters to settle on, and they're out in the water as larvae looking for a place to settle that's hard, where they can attach and then grow up into an adult oyster, when we create those kinds of places, we can create them in a way where we can also try to protect the shorelines. So that means building some kind of a reef, some kind of a structure out of old oyster shells, out of concrete, some kind of materials like that are hard that the oysters will settle on. And if we do that at a large enough scale, we can break the waves, we can accrete sediment, and we can have some effect on these kinds of physical processes that affect our shorelines.
Maybe also, could you touch a little bit on the idea of nature-based solutions? Obviously, Living Shorelines is one of many approaches that are looking at how you can use nature-based solutions or hybrid solutions, and not just gray infrastructure, levees and dikes.
Right, so San Rafael Shoreline is actually a great example of a place that's largely riprap along our bay front. And riprap is one solution to protecting a shoreline. It just tends to provide very little habitat. So we're interested in this concept of living shorelines. This simply means creating some kind of a structure that has shoreline protection benefits, but which also creates great habitat. So it is this hybrid approach. It's something that has somewhat of an engineering solution to shoreline protection, but it's based on natural products, natural habitats, and those things that living organisms can provide for that shoreline protection. So that's a direction that we're trying to go. as we're thinking about sea level rise and how to protect our shorelines, moving more toward creating oyster reefs, adding eelgrass beds, doing more marsh restoration, these kinds of living habitats that also provide shoreline protection.
Can you say what riprap is?
Oh, I'm sorry. Riprap is usually quarried, mined rock that's just placed along a shoreline. So you've seen it everywhere, yeah.
So our second stop, sorry Kathy. Our second stop is going to be the Tiscornia Marsh, which is just adjacent to the living shorelines and on our way back into the canal. So we have Stuart here, Stuart Siegel. Maybe we can get you to talk a little bit about wetlands in the bay. In 1800, there were 190,000 acres of tidal marshes around the San Francisco Bay, but in 2009 it was reduced to 46,000 due to development. And we've had a great tradition of activism, Save the Bay in 1961, that ended up helping to limit development in the bay. And then more recently, in 2006, voters approved a parcel tax, taxing themselves $12 for wetlands restoration. And now the scale is something like 100,000 acres of marshlands that will be restored. So can you describe the role of wetlands and marshes in the bay, and also how the Tiscornia Marsh fits into that broader picture?
The role of wetlands in the bay, that's a big question.
Yeah, sorry.
So we've been, what's interesting is the region has been focusing on wetlands restoration since the 1960s in the Bay Area. And really that started from understanding of the ecological impacts from all the loss of wetlands that had happened since the gold rush in California, from diking off for agriculture, diking off for salt ponds, salt production, and for development. And there was a real, as she mentioned, there was Save the Bay back in the 1960s as a push to stop filling San Francisco Bay and try to reverse that trend and restore those natural wetlands as part of the system. We've come to really understand wetlands as a lot more today than just habitat for endangered species and for other plants and wildlife, of which they very much are. Today, in addition to that, we really understand the benefit of wetlands to human society, and this actually goes well beyond wetlands. Watersheds are clean water for our drinking water supplies. Wetlands provide a role for attenuating floods, for cleaning up the water, and for providing shoreline protection. They sequester carbon, so in the era of increased greenhouse gases, restoring wetlands is a mechanism to bring carbon out of the atmosphere and back into the ground. So they do lots of different things for us. So it's interesting, the focus on restoration has long been there, and the endangered species recovery is still a huge part of it. And if you always think about endangered species, it's a big part of it is that those individual species are the canary in the coal mine. They tell you something is wrong with how the ecosystem works, in addition to them being endangered species unto themselves. And so the fact that you have the delta smelt and the delta little tiny fish, it's more than just about the fish. And the fish just tells you there's something wrong. And the same in the bay with the clapper rails, now ridge-rays, rail, saltmarsh harvest mice, other species. So in this sort of newer understanding of the role of natural systems in helping the human society, the idea of wetlands as a shoreline protection mechanism is really gaining a lot of traction around the world. It's by no means just in San Francisco Bay. And so the idea of having large swaths of wetland is this idea of nature-based solutions that Kathy talked about, is that there's living shorelines have all these elements to it. There's oyster reefs on part of it, there's wetlands, there's beaches, there's very gentle slope upland transitions to where we live. All those pieces are components of living shorelines, and you can add all of them in one place or pieces, whatever you can kind of fit in the landscape. And that's the idea of bringing nature-based solutions to helping human society protect against flooding from sea level rise, flooding from major storms, and improving our water quality, making our bay more swimmable. For example, we're going to go out and do we call this contact recreation when we're out in the kayaks and you get water on you. And there's water quality standards for contact recreation because the bay didn't used to be clean. And if you went out 50 years ago, doing today, you might not like what happens, right? So we've gone a long way to clean up the water quality for simple things like contact recreation. So Tiscornia Marsh, Santa Fe is interesting that as Jeff mentioned, where we're standing here, all the way downtown to like D Street was wetlands, tidal marsh. And the creek, this is tidal right here, obviously the tides up and down. The tides go all the way to Davidson Middle School and Muffin Mania, if you know Santa Fe. They go up under the freeway, they go deep into downtown as well as along here and out of the bay. And Santa Fe has almost all of its wetlands lost. So there's virtually nothing left in the city limits of Santa Fe on this side of the hill. On the China Camp, Galenas Creek, which is the city limits, also has some. Here, pretty much all we have left that's tidal marsh is a couple little pockets here and there, and then Tiscornia Marsh, which is out by the Alboro Community Center, and we'll go there today. And it's quite small, and it's a little pocket marsh as well. And that's it for the entirety of the Santa Fe shoreline. And as Kathy mentioned, it's